Today we're going to be going through chapter 4, number 7 from page 77 in your textbook. And it talks about a train going at a constant 60 kilometer per hour, moving east for 40 minutes, and then 50 degrees east of due north for 20 minutes, and then west for 50 minutes. And we want to know the magnitude and the angle of its average velocity during the trip. So if it was asking for the average speed during the trip, this would be a really quick question and we'd be done because the answer would be 60 because it continues to move at 60 kilometers per hour the entire time. But unfortunately, it's asking for the average velocity, and we know now that velocity includes magnitude and direction. And so since we're going three different directions this trip, we care about the direction. And so we have to work that into what we're doing here. And so I've drawn a quick picture. Sometimes if you're dealing with north, south, west, and east, it's a good idea to draw yourself a bit of a compass here so you don't accidentally forget a direction when you're doing that. And so I've just sketched it, not to scale because we're not entirely sure of the scale yet, but we go east for 40 minutes. I'm calling this segment 1. And then we go 50 degrees east of due north. Now that's a little bit strange if you're not used to it. What that means, if I ever see anything of due north, I draw a vertical line because that's my north line. So if I'm east of due north, I would be towards the east that much. And so that 50-degree angle is right here between the north and towards my east. And then my third segment, I'm going to be for 50 minutes in the west direction. And so that's in our negative x direction if we're considering this to be an axis. So what I first did here is I wrote out what my velocities are for the different segments of my trip. So for segment 1 right here, it's 60 kilometers per hour I hat because that's in our x direction. For segment 2, what I did, since we are given this angle right here, east of due north, I sketched in 40 degrees right here because it's typically easier with our familiarity with trig to work with angles that are on our x-axis. And so I have 60 times cosine 40 for our I hat, and then 60 times sine of 40 for our j hat, and I put our units over here. And then for a third segment, it's only in our x direction, but it's in the negative x direction now, and so that's negative 60 kilometers per hour I hat. Now, what we can notice here is that if we just try to add up all of these vectors to figure out our average velocity, that would not work well because you can see if I add segment 1 and segment 3, 60 plus negative 60 would equal 0. But we know that this part is traveling for only 40 minutes, whereas this part is traveling for 50 minutes. And so we know that that shouldn't equal 0. And the way that we can work with this is that we can figure out what is our position vector, because we know our average velocity would also be final position minus initial position over time. And if we're considering our initial position to be at 0, 0, then we can figure out our final position and find our average velocity. So here we go. I want to figure out position vector for our first segment. And so in order to do that, I'm going to take my velocity and multiply it by the amount of time. And so I will have 60 kilometers per hour times 40 minutes. But as you can see right here, my units don't work out. And so we can multiply this by 1 hour per 60 minutes. And of course, those cancel out, and we're left with how many kilometers we go, which you can see pretty easily mathematically is going to be 40 kilometers. And this is a vector, so we want to make sure that we are including our unit vector notation. So that's in the x direction, so I hat. So then position vector 2, we're going to take our velocities and then just multiply it by our 20 minutes. And so, of course, we'll do 20 over 60 so that we're using our hour units. So we have 60 cosine 40 times 20 over 60 for our time, plus 60 sine 40, again, times 20 over 60 for our time. And so we get our position vector 2 is going to be, if you work this out on your calculator, you'll find it's 15.32 kilometers I hat plus 12.86 kilometers j hat. And so that's how far we go on this segment. So then our third segment, we are going to take our negative 60 times our time, which is 50. So 50 over 60 to make sure that we're in hours. And we find out that we are going negative 50 kilometers I hat. So now I have all three of my distances. And our next step is to figure out what is my total distance. So position, total, and of course, since we're dealing with unit vector notation, we add up all of our I hats, and then we can add up our one and only j hat. So 40 minus 50 is negative 10. 15 plus negative 10 would be 5. So we have 5.32 kilometers I hat. And then this is the only thing we have in the j direction. So that will be plus 12.86 kilometers j hat. Now, our last step here, as we talk, this is our position vector, assuming that we're starting at 0, 0. So from 0 over to 5.32 to 12.86, this is our initial, this is our final. And so in order to get our average velocity, we would just do our final minus initial, which is 0, divided by our time. And so that means we need to know our total time. And so we traveled for 40 minutes, and then 20 minutes, and then 50 minutes. And so this will equal 110 minutes. But of course, we want to know our speed in kilometers per hour. And so 110 minutes divided by 60 will get us 1.83 hours. So our last step here, or almost last step, our average velocity is going to be 5.32 kilometers over 1.83 hours I hat, and plus 12.86 kilometers over 1.83 hours j hat. And so we'll find out that our average velocity is 2.91 I hat plus 7.03 j hat kilometers per hour. So we did that by finding our position, dividing it by time to get our average velocity. Our last step is to get the magnitude and the angle. So in order to get the magnitude, we would just use the Pythagorean theorem. So for part A, we would have the square root of 2.91 squared plus 7.03 squared. And this will turn out to be 7.61 kilometers per hour. So here's our magnitude. And then our angle, we will just do, we know that tangent of theta equals our j hat over I hat. So 7.03 divided by 2.91. And if you do the arctangent in your calculator, you'll find out that this angle, which is this angle right here, is 67.5 degrees. And that is it.